So today's lesson in 2.8's lesson is going to feel very similar to what we did in Chapter 1. Our first postulate that we're going to talk about today and what we've mentioned before is what we call segment addition postulate. And you'll see me abbreviated as segment addition postulate. Okay? Segment addition postulate says that if A, B, and C are collinear, meaning they're all on the same line, then point B is between A and C if and only if segment AB plus BC equals the whole thing, which is AC. Sometimes you'll see me write this as part plus part equals whole. The first part, AB, plus the second part, BC, is going to equal to the whole thing, AC. Okay, so the first few problems we're going to be doing is nothing really new. We've done this before. Example 1, use the diagram to find KL. Again, to do this, you're using segment addition postulate. You would say part plus part equals whole. Our first part is JK, our second part is KL, and the whole thing is JL. Okay, so once you plug in the given information, you have 15 plus KL is what you're looking for, equals 38. So to solve for KL, you would subtract 15. So KL is equal to 23. All right? So that's how you would do that one. Okay? If I go ahead and move on to our next one, B, number 2 says points A, B, and C are collinear, and B is between A and C. So if I go ahead and draw this, okay, B is between A and C. You don't know where it's at, but that's what it looks like, something like that. If AC is equal to 3x plus 3, AB is equal to 1 plus 2x, and BC is equal to 11. Okay? So to set this up again, I'm going to say part plus part equals whole. All right, our first part is AB. Our second part is BC. And then last AC is the whole thing. All right, so when I plug in, I have 1 plus 2x plus 11 is equal to 3x plus 3. I'm making sure, double checking my numbers here. So right here, this will give me 2x plus 12 is equal to 3x plus 3. All right, when I subtract 2x, I get 12 is equal to x plus 3. Subtract 3, and I get 9 is equal to x. Okay? On this problem, they want me to find AB, and AB is the length 1 plus 2x, so 1 plus 2 times 9. That would give me 1 plus 18, so that gives me AB is equal to 19. All right. Okay, let's go ahead and move on to the next page, or the back of this. The next part, they're going to talk about the properties, the reflexive, symmetric, and transitive property. We talked about that last time, and now we're going to talk about how it applies to segments. So the reflexive property of congruence for segments, if AB is congruent to AB, then that would be your reflexive property, because they are the same on both sides. Symmetric would be if AB is congruent to CD and CD is then congruent to AB. Remember, the symmetric property is like the switch, okay? So they just swap it around or flip it. Transitive property, if AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF. The first and the last, remember, we cut out the middleman, okay? Here's a proof proving the transitive property, and I'm not really going to go in depth in there, but that's pretty much showing you why the transitive property is correct. Okay, you're going to also have something on your worksheet that I'm just going to ask you to state the property. So for number 1, QA is equal to QA, that would be the reflexive property. Okay, the same on both sides. Number 2 says if AB is congruent to BC and BC is congruent to CE, then AB is congruent to CE. Again, they cut out the middleman right here. So yes, it's the first and the last. That would be the transitive property. Okay? And you could say a congruence if you want to. The next one says if Q is between P and R, then PR is equal to PQ plus QR. That would be your segment addition postulate on the first side. Okay, on the other side. Segment addition postulate. Okay, and then the last one says, if AB plus BC equals EF plus FG, and AB plus BC equals AC, then EF plus FG is equal to AC. Right here, they're saying that AB plus BC equals EF plus FG, and also AB plus BC equals AC. Then you could say that this was equal to that. This is actually just the substitution property. Because they don't have it written where this is written again, then it's not going to be transitive. So this is just the substitution property. So if AB plus BC is equal to two things, then we can set them equal to each other. It's just the substitution property.